I'm Jeremy. I'm program manager for ArcGIS Online JavaScript API. I have a background in geography. I've always been interested in data-driven mapping. And I'm here with...
I'm Christian Ekenes, product engineer, also with the JavaScript API. Yes, I'm very interested in visualization mapping. That's what I tend to focus on. That and the smart mapping project, and also Arcade. So
yes. All good things. So this session, if you've come to this session in the past, I think the first bit will be similar. You'll see a lot of similar concepts, and then we'll show some new stuff towards the end.
Yep.
You jump in anytime, man. So what are the different things that we can visualize? We can help you understand where things are, what is there, how much is there, when it happened, and then you can do mix and match those if you want, create multivariate examples of them. So where something is, it's pretty self-explanatory where those dots show up. What something is telling you distinctly what are those different types of features. How much, thematically, driven by numeric data. When, by a date. You can also think of age, other things, and combining the two.
I can go over this stuff if you want. Okay. So I just want to point out that this is all about 2D, and we're going to have an equivalent 3D session tomorrow. So if you're interested, I encourage you to look it up. We'll cover sort of the same concepts, but obviously with the focus on 3D, and it will be very different actually. But it's just that conceptually these symbols and renders apply to both 2D and 3D. So I just want to point out that it's pretty consistent. So fundamentally, visualizing features or data in your view, it comes down to the symbols. These are all the symbols that we support in 2D, and it's basically, I've sorted this slide by type, so you can see that points, we call them marker symbols, and lines, you just have one symbol type, and then polygons you can actually do quite a bit with. We have fill symbols, picture, which include filling with color and also with images, but you can also take advantage of the markers with the polygons as well, so you can place those in the centroids to render your data. And that's particularly helpful for size visualizations.
Some things that we're working towards is introduce more sophisticated symbology. So the same kind of symbology that you can do with ArcGIS Pro, we'll eventually be able to do a good, not everything, but a good chunk. Most likely, I mean, the biggest feature would be to do vector marker symbols, and having multi-layer symbols.
All right, and something that I know that I take a lot of pride in with our API is that it's relatively straightforward. It doesn't take, it's not a steep learning curve to get up to speed on how to create symbols in JavaScript. So this is just an example. You can see that green marker symbol off to the right. This is what the code looks like. You just you create a new class for simple marker symbol. You can set the style to diamond. We have something around 6 or 8 styles available to you out of the box. But of course, Jeremy said that once we release this idea of vector symbols that will come out later, you can basically do whatever you want there in that space as far as the style. And then then you define the outline with the width in pointer pixels, and then you can set a color for the outline and also color for the fill. And so that's exactly how that code would look there. Then the simple fill symbol, it's very similar. You just set your fill color and then your outline. So it's pretty straightforward. So when we talk about data-driven visualization, or I guess visualization in 2D, the stuff that's really interesting to particularly the GIS folks or really anyone out there. You see really popular maps in things like the New York Times or on other websites. And a lot of that is data driven. It comes from something like the Census Bureau or companies like Uber. And when we talk about the ArcGIS API for JavaScript, the data needs to be hooked into one of these sources. So it could be the feature layer. That's where the vast majority of our samples use, because we take advantage of a lot of capabilities from ArcGIS Online on the service side. But then we really focus our development on the feature layer. But along with that, there's also the client-side data sources, such as feature collections. So if you pull your data from another source on the web, you can create a feature collection, or maybe it comes from some other process in the ArcGIS platform. And then there's CSV layer, and now GeoJSON layer is going to be coming out in just a couple of weeks or 3 weeks. And then stream layer for live data streams, and also map image layer, which is the ArcGIS map services that are rendered server side.
Map image layer there is kind of the odd duck. You're not going to be working with features with that layer. You're going to be asking the server to generate an image based on the definition of your renderer and symbology. And it'll generate the image on a server and bring it back. Everything else, all the other layer types, are all dealing with features in the browser. Stream layer is being pushed features from some source directly into the browser versus querying it from the server.
But the thing that's neat about our API is that you can set it's the exact same rendering APIs. So you can pass those to your map image layer, and though the implementation is different, it's the exact same code used to create the same visualization.
Yeah, and you don't have to. The beauty of these layer types is you shouldn't have to get into the mode where you have to be parsing data, mangling it together, and then creating like individual graphics with symbols and pushing it on the map. Use this layer abstraction, because then it allows us to apply these client-side or server-side rendering techniques.
Yes, and so those layers have data fields, and that's what you're going to probably be using most of the time is referencing a field such as population. Maybe it's some kind of monetary unit like spending, or some other count or type. But we also have the notion of client-side expressions that allow you to calculate fields in the client and derive the data based on that. And so this is an example of, say you have different educational attainment variables. So the number of people who completed a bachelor's degree or a master's or PhD, but you really want to just visualize what's the percentage of the population that completed college. But you have it broken up into multiple fields, add them together in the expression, divide by the population, and you can get a value instead of calculating that in the service.
Yeah, this part's really important, because you're not, you don't have to go and create that new field, do that field calc, process the data, and get a new field, which is percent college attendees. You can let the raw data lie how it is, and then on the client, produce the result you want.
And so the core concept of visualizing or creating a data-driven visualization is this idea of renderers. And this is what Jeremy was really getting at just a minute ago when he was saying you don't create an individual graphic and have to create a symbol for each one and display it in your view. You can let the renderer handle that for you. And this is where the API gets really powerful. So here are some of the most, these are the core renderers really that we support. We have a lot more that we're going to go over in this session, but just to start off, like there's a simple render. So here we're taking a look at just freeways and cities in the US, and there's not really data that's being shown here other than where those things are. And so that's where the simple render is all about. It's just give me the same symbol for all these graphics. You just do it once, and then it does it for all your features.
You can do some cool things with that, though, like Christian showed in the plenary when he had all those flood warnings laid on top of each other. Those are all the same symbol with a simple renderer. It's just that symbol had like 95% transparency.
Yeah, and so that allows you to see where things tend to group or congregate more. Unique value render, this particular image you see is using these educational attainment variables I alluded to just a minute ago, where you have the number of people who completed primary school, secondary school, high school, college, and so I wanted to visualize in these cities in Mexico, what is the predominant attainment type? Which level of education did most people attain in that city? And it turned out to show some really interesting patterns. And I'll show this map a little later. And so we can just use a solid color to indicate that. That's a type. It's saying most people completed secondary school in this city or college. But the more common scenario is maybe it's a category like high, medium, low, or like a region or something like that. And then you have class breaks renders, which is a very classic way of visualizing how much of something exists. This is a little complicated, though. It really, it came about from the print world, right, Jeremy? Where you have, it can be complicated to explain, first of all. It's complicated to figure out what works because you have different classification methods, quantile, standard deviation, natural breaks, equal interval. Mm-hmm. And it's hard for, say, a GIS analyst to even really know which one is the appropriate one to use in a particular case, and it's hard to explain that to the user. How do they know that this particular visualization is telling them something? Because any of those methods can give you a vastly different visualization.
And it creates these kind of hard lines too, like why is that 35 to 50 this light purple, and then less than 35 is dark purple? Does that mean, what is 34.99? Oh, well, it's dark purple, but it's really close to 35. So, like Christian said, it's a vestige of the print world, where you needed to be able to print the map out, look at the legend, and look at the no more than 8 colors, find the color on the map, find the color on the legend, then you know what it is. But in this digital world, you just touch the thing and it tells you what the value is. So you don't need, the legend is more of an overview and not a critical must-have to understand the map.
However, we do support that render. So
and it can work in certain cases that are very important, so it's not
Yeah, and here's what it looks like in code. So again, this goes along the same thing with the symbols, like with the simple render. Just give it a symbol. That's all you have to do, and all the features are rendered the same way. Class breaks, you basically, you don't set a classification method here on the core render. You manually define each break, and so that's why this one can get particularly dangerous to use if you don't feel confident with what you're doing, if you don't have set breaks already. So you just say, give it a min value and max value and a symbol for each one, and it will render it the way you would tell it. Unique value renderer, this is sort of similar in concept. You're just setting a type and you're matching it to a symbol. So if I'm doing election data, so right here I'm actually using the arcade expression. I don't have a field that tells me who won the election in a county. But I do have the count of people who voted for a Republican, a count for who voted for Democrat, and an independent or maybe other party. In this case, I'm just writing a pretty straightforward arcade expression where I'm grouping those into an array, and then I'm saying I want to find the maximum and then match that max with the appropriate label. And then you see in the unique value infos that I match that label with a different color. And so that's how you can achieve a pretty basic election map using arcade. But this is what the concept of visual variables is. This is a property of the renderer, and it's all about numbers. And this is where I believe our API really shines, because as Jeremy explained with the class breaks, when you have a set hard break, you don't really know. I've heard people say that what's nice about class breaks is that it breaks it up into discrete colors, and so you know exactly what you're looking at. It's like, well, no, you don't really know what you're looking at. You don't know what value that feature is. And the thing that's nice about the visual variables is that it maps it along a continuous ramp. So if you're dealing with color, look at this middle image. This is the percent of the population in poverty. Some would say that looks like a lot of class breaks we're using. It's just 2 stops. I want the minimum value of, say, 10% to go to this really light beige color, and the maximum of, say, 35% to go to this purple color. And that way, you can roughly see how the population that is in poverty is distributed in this area. But granted, you don't know those exact values. You can't see the color and match it exactly to the legend. But as Jeremy pointed out, you can touch the feature and get the information.
And it just listening to you talk about Christian reminds me back in the day in ArcView. How many people used ArcView? All right. Who knows the maximum number of classes you could do in a class breaks render in ArcView? Anybody remember? 30. That was the max you could do. But I would always be like, I just can't see it. It's not clear that these 4 or 6 classes, I'm going to bump this thing up to 30 and go through this red or blue scale so I can actually, see the variation of what's happening. That's sort of the inspiration for doing a lot of this.
Yeah, and you can do it size, color, opacity, and even rotation. So you see examples of all that on this image. And this is what it looks like in code. So you set a type, and that's exactly the types I just told you are the exact values you would set. Then you set the field. You say, I want to drive the color of my data based on this field. In this case, the population in poverty, but because I want to make it a cartographically sound map, I'm going to normalize it by the total population, and then I'm going to map colors between 2 different stops, or more even, if you wanted to. We actually do set a limit of 8 stops now with the latest version because we use WebGL, and we want to really set a spec there so that so that we make a good visualization. And then we linearly interpolate the colors depending on the value between there, so that those midtones fall somewhere between 10 and 30% based on those stops.
This is also a good way to not let the outliers drive your visualization. So what this is saying here is anything between 0.1 and below is going to get that color of white or yellow. And anything 0.3 and greater is going to get that color of purple. So that allows you to not let the outliers drive the visualization. You can focus it, unless the outliers are important, depends on what's important, but let where the majority of the data is drive the visualization.
All right, well, let's dive into some examples to see how this actually looks in some real world scenarios. Okay, so here's the simple render case. Some of you may recognize this as earthquake data. This is actually the live feed from the USGS. I'm just pulling in the CSV and putting the points on the map. It's a simple renderer. But we might want to see something more interesting, right? Like, how big were these earthquakes? What's the magnitude? This is where visual variables comes into play. So if I flip over to my code, let's find this particular app. So, right. Can everyone see this code, or should I bump up the size? Bump it up? Okay. And
This room is always the worst to present in. It's so bright.
Oh, is it? Should I bump it up some more? Are we good? Okay. So here's the URL to the live feed, and then I'm just setting that to a CSV layer. And then I can set my render. And what's nice about the JavaScript API is that we implemented this notion of auto-casting, so you don't have to require your renderer modules up in the top and have this super long list of modules. You can just pass in an object and set a type on that object, in this case simple, to note simple renderer, and we'll import that module dynamically for you. And then I'm setting this kind of deep red color on it. But if I want to look at earthquakes, I want to see the magnitude. So here's a visual variable that I'm calling magnitude with size. So I just set the type to size, set a field of magnitude, and because I know the data's anywhere from 0 to 10, I'm going to just put some map sizes to some magnitude values. And then I need to put that on the visual variables property. So I just say visual variables, and then magnitude with size. Save it, let's refresh it, and there you go. So it's pretty straightforward API. Okay, let's take a look at this example. This is the cities of Mexico data set I got. Simple render, just setting a gray symbol, nothing interesting, right? Maybe this is interesting to some of you, but I want to see some more data here. So if I take a look at this one, I want to take a look at education. And one attribute that really popped out to me, I know this field name doesn't make any sense to anyone. This is the number of people who do not have any formal education, as in they did not go to any school, and they didn't go to any preschool, not even any like elementary school. They just didn't go to school. So I'm like, interesting, I want to see what that looks like. So I create a visual variable, and I want to do color because it's polygons, and I set the field to this one, and then you're probably wondering where I got these values. I just got them from ArcGIS Online, but basically you'd have to be guessing at this point if you wanted to explore the data with just this API, and we're going to talk about how you can work around that using smart mapping a little later on. And I'm using this nice white to blue color ramp. And I'm going to set a meaningful title and put that visual variable on my renderer. So here's a simple renderer, visual variables, and population, or what was the name of that one? No education is what it was called.
Yeah, the nice thing about the visual variables is they can be applied to any of our standard rendered simple render unique value class breaks.
And so, how many of you are familiar with the geography of Mexico? Like where the major cities are? Okay, cool. And I know Jim here on the front row is probably cringing because he's a cartographer and he looks at this and says, why are you mapping total counts? And if you're familiar with the geography of Mexico, you'll probably note that the major cities really pop out. And so this gives you a false, this is one of the, if you're not a cartographer, not a GIS person, but you're a developer, and you just want to learn more about visualization, this is kind of one of the first cardinal sins of mapping, is you don't map total counts on a choropleth map like this one, where you fill polygons with color, because you're just going to see population trends with demographic data. And so the visual variable allows you to normalize your data. But you got to remember to take a couple of things into account. So I've got the snippet here. Oh no, that's the non-normalized, so that's what I'm already using. If I take this one here, you'll note some major differences. First off, I'm going to normalize based on the total population. But note that I have to update my values. I think this is a common thing that some of you might run into is, oh, I need to normalize, or I didn't normalize properly. And as long as you're updating your values, then then you'll be fine. So here it's a ratio, so it's going to be between 0 and 1. So 0, the deepest color is 18%. So that would be 18% of the population or more did not go to school. So I get a completely different looking map. And it's kind of interesting. I see that Mexico City and some of the other bigger cities, actually, they don't have that same, they don't really show that trend. You see these rural mountainous areas in Oaxaca and other parts like Chiapas here, where a lot of the population didn't go to school. So it's an interesting pattern. Anything else, Jeremy?
Well, the one thing you gotta watch out with normalization is that it's just dumb normalization. Divides one field from the other. So that's really just a ratio. And then if you want to do a percent, you'd need to either update your label, which you could do, or do an arcade expression where you could divide the two and take it times 100 and maybe round it so it looks good.
So let's go ahead and do that. So arcade, you access your field using this dollar feature global. So here I'm just doing a division. So this is exactly what would be going on if I did my field and normalization field. But instead, I'm going to round that and
take it times 100.
Multiply it by 100. And then, of course, I gotta update these values. So let's, move this decimal over. One more right here. And there. Oops. There we go. And that way, it's going to be the same spatial pattern, but you see the legend looks a lot better, right? It's more readable. And in fact, I already put % population, so it was telling me a lie already that it was a ratio, it wasn't the percentage. So
notice the outlines are, they're not overpowering the map. They probably even could be taken down further, but that's one thing you got to watch out for is you don't want the outlines to drive your map visualization. They can just screw it up. And it's already pretty low, but if you did it even more, and then
we got some slivers.
This data set's not the best because the data is slivered,
but that looks a lot better. Yeah.
Just something to watch out for.
So another thing, outlines. Keep them down because otherwise they dominate. Let's see, what else do we got? So this was just another one. It's % of households in Boise, Idaho earning less than minimum wage. This was another example of arcade, but since we showed that to you, I'm not going to dive into the code. This is an example of the rotation visual variable. What's different about this one, so this is, you'll note that there's actually 2 visual variables. It's not just rotation, it's size. So we're mapping wind. So how fast was the wind going, and also which direction was it blowing. So in this particular one, let's see here. Let's do here. You see this renderer. Note there are no stops here. All you have to do is say rotation, set the field, and then the rotation type. So I'm saying geographic. I want the rotation to start at 0 degrees north. So,
can you use field expression?
You can, yes. You can use arcade expressions and all the visual variables. Which
is pretty nice because maybe your data doesn't exactly, maybe it's not wind. Maybe it's, you want to have a left arrow if the result is 1 and a right arrow if it's something else, then you normalize between that.
All right, so I mentioned election earlier. Let's take a look at this one. This is a pretty typical election map, you could say this came from 2012, so it's pretty dated. But even from the 2016 election, it looks somewhat similar, even though you had vastly different results. In this particular election, President Obama won, a Democrat, but most of the map looks red, even though he's represented with blue. President Trump won in 2016. He's Republican, he would be represented with red, but his map looked somewhat similar, though these counties up here in Iowa flipped to his color, and probably some others as well. But it basically looks the same, so how could we have vastly different results, right? So we could use visual variables to our advantage here. So looking at this code, I just created this convenience function for setting the basic symbol. So I don't want my outlines to be overpowering, so I make them small. This is what the current render looks like. Just setting that default. So if some other candidate won, which never happens these days on the county level anyway, we'd give it a green color, and we map the Democrat candidate to blue and red to the Republican. But if you want to be a little more insightful, we could add some additional context. So let's take a look at the percentage of the winner. What's deceptive, well, that map is a good map. It's not telling you any lies, but it's also deceptive. I mean, President Obama won that election, and we could get a sense of what happened in each of those counties using other things like opacity. Let's set an opacity visual variable where we say, I want to see the percentage of the votes that person won. And so I'm just going to say share of votes won, and then say if it was around 50%, that was a contested election. We're going to give it very low opacity, okay? If they got 75% or more of the votes, we'll say 95% opacity, they won in a landslide. Let's go ahead and add that to my visual variables and refresh the map, and we'll get a different picture. If it draws, there we go. Not all that different, I guess. We still see lots of red, but it's interesting because we see that these Midwestern counties, Utah and also Appalachia, are very strongly Republican. So we did learn something new, right? Not just the winner, but that they really carried that candidate. But what about the actual numbers? So that's where size can come in. So we can map the total number of votes cast in the election. So this is voter turnout. I'm going to say minimum value 100 to, looks like 1 million votes. And if it's 1 million votes or more, we're going to say it's 60 pixel marker. And if not, then 4 pixels. Note that I'm rendering these with a simple fill symbol, so I'm going to go ahead and flip this to a marker symbol because size has no concept with the polygon. Like sizing the polygon wouldn't make sense. We can't just render cartograms on the fly here. So let's go ahead and do the size, total votes. Oh, I didn't switch to markers. So if I hit true, again, this is why I created that function just to make this a little more convenient. Okay, we should get a different visualization. I don't know why it's so slow right now. There we go. So now we see a vastly different map. That's just a demonstration of how, oh my gosh, this is taking forever. It normally renders faster. I'll blame the internet.
I blame this room. Blame this room. First presentation I ever did at Dev Summit 12 years ago was in this room, and it was when raster tiles just came out, and I was like, look at how fast they're loading. Boop.
So, and now we see a different picture. Now I can see, oh, President Obama won these bigger cities by a pretty big margin, and and he won the election. Of course, this is, all not telling the whole story because there's the Electoral College and all of that, and so we're not going to get into that. I just want to look at the popular vote, and so now we kind of see a better picture of what happened in the election. A lot of, we see an urban versus rural trend, and we see who won, right? Mm-hmm. And I think that's the last one on this section. Let's move on.
Oh yeah, good. I was just going to say that.
Go ahead. Go right ahead.
Oh, well, I wasn't going to exactly say that, but yeah. Okay, so that looks like super complicated. I mean, it doesn't look super complicated. It's easy. But that was quite a bit of code you had to write there, and you had to figure out what those values were. And Christian even said it. He's like, the way I usually get those values is I go to an ArcGIS Online and I'll set it up. Well, that's why we've made smart mapping. Smart mapping gives us gives you the ability to come up with a good default based on the data that you're looking at.
So the API is simple. It's the numbers that
the numbers that
hard,
are complicated. But even in the API, it's a lot of code to write. If you did do the whole thing in online, saved it as a web map or as a layer, then you would bring in one line of code into your app versus having all of those lines of code. But back to smart mapping. You want to talk through this one?
Oh, sure. Yeah. So the concept of smart mapping is maybe you don't know your data very well, but smart mapping, or maybe you don't know the colors that work well with your base map. This is where smart mapping steps in. So the idea is to have a simple API that gives you what you need, a good starting point with your visualization. So in the center, you have this smart mapping creator method. Basically, it's pass in some parameters, give me back a good visual. That's what it's all about. So you have to pass in your layer, you pass in a base map, and in some cases a view. If you're using Arcade, we require you to pass in the view instance. But then you pass in, basically it comes down to layer, base map, and your attributes. So I want to visualize population and poverty and with this layer. And I want to render it on a dark base map. So give me a good visualization. So you pass those to the method, and if necessary, it'll generate an Arcade expression. I'll go into that in just a minute. But basically it'll query the statistics on the layer, get a color scheme based on the base map you provided, and then it will give you the renderer back. And you just take that render that and apply it to that input layer. And so it's a pretty awesome concept, actually. You can do a whole lot of fun things with it. It's not just for authoring applications such as ArcGIS Online, but you can create some pretty cool data exploration applications using this.
It is a expensive process, though. So you don't want to shortcut your code by using it for every app so that every time the app runs, it does all of those calculations. Either you have a dynamic app that's for data exploration, or you either put your renderers with your visual variables in code, or you put them in a web app or a layer and you load that.
Cool. So Jeremy and I are heavily involved in the Arcade project, and something that came about early on with Arcade was there's some common types of maps that you can create with Arcade. And just to show you a few of them that came out pretty recently, there's age. So let's say you have 2 date fields and you just want to map how old something was. So in this case, it's the inspection on streets. So when was the last time this street was inspected? You can pass in both of those date fields to the Arcade method, and it will construct this Arcade expression for you and give you back a render with a continuous color ramp above and below. And you can map age that way. Also predominance. So I was talking to you about predominant education in Mexico. There's cases where you have subcategories of your data, such as election data. You have candidates who earn votes. There's race. So you have different races that live in a population. There's educational attainment. In this case, it's languages spoken at home. They all are subcategories of really the same variable. In this case, it's people. And so if you want to say, I want to know the predominant category of a particular area, you just pass in all of those fields, pass it to the smart mapping method, and it gives you back something like this. Not necessarily with these exact symbols, but it'll give you the colors back, and you can gain insight from your data that way. I'll show you an example of that one in a bit. Relationship is one that's new this year. And so the idea is that you can pass in 2 number fields and try to explore the relationship between them. In this case, this is a very classic relationship example. You have the percentage of the population that is diagnosed with diabetes, and also the percentage of the population who is obese. And you can map one of those. So in this case, diabetes goes from this low color to a bright pink color. And then you have obesity, which is the opposite. It's the low color to the blue color. So in areas where you see just this white color, such as Colorado, that's an area where both of those values are low. And if it's strong obesity but low on diabetes, you see this bright blue show up. And then likewise on the other end. But then when those 2 variables agree with each other, so to speak, you see a pattern. So you see, again, Appalachia, the Deep South, the Carolinas, where both those variables are high.
And this is, like Christian said, all of these examples, these higher level styles are under the hood, they're just Arcade expressions. But the smart mapping APIs and the ArcGIS Online will generate those for you based on your data. Actually, all the relationship style is really 2 class breaks renderers where for each of the variables combined to create a unique value representation.
Yeah, so we're using the existing renders we already showed you, but creating this really big Arcade expression, because otherwise that would be a very difficult expression to write by hand. So we give you this method that generates it for you.
One last thing, just on go back one. Yeah, if you try to do this by hand, it's a ton of work. You need to, for each of your fields, you need to figure out what the class breaks are, calc the values for each of those breaks for each field, and then create combine them together to create a unique combination, and then create a custom unique value renderer with a custom legend in Photoshop, and then you're done. So that's a huge process. That's like a week. Whereas with the smart mapping APIs, you can just say, hey, this variable, I want 2, 3, or 4
classes.
by 4 classes, and boom, you're done. And then I've got a great color ramps from Cynthia Brewer to apply on top of them.
So I'll show you a quick example of this. Let's see here. So this is the predominance of Mexico, that map I was going to show you. I'll just show it off again. So this was used, I wrote the expression myself, actually, in this particular case for predominance. This is what it would look like. So it's a little long, as you can see. So creating this, it took a bit of time to figure out and to tweak and to get just right. So smart mapping takes care of that for me. Let me find, okay, this was another, let me go like this. This was another interesting map where I wanted to take a look at the, this is, again, wrong. This is not the predominant educational attainment. It's actually housing. So the most common decade of housing for each census block group. So you can see this outward growth from the inner city all the way out to the rural areas. So most homes in this yellow region were built before 1940, and then you see as they built out, the predominant decade in which they were built is shown there. But this is the Smart Mapping API here. Let's see here. I have a layer. I'm calling it poverty layer. And then I want to render based on poverty. So I say, I want to pass in my layer. I want to set this light gray base map. I could also just say gray, because that's the Esri base map. And then field is population and poverty. Poverty, I want to normalize by the total. And I don't have to set the min value. I mean, that's if I already know what's going on. And then I want to generate it. So all I do is I pass those parameters into this render creator function, and again, apply that result back on my layer. And we have this helpful slider widget to help you kind of explore and to tweak the visual. So the default looks like this. It's kind of hard to read. If you bump this up to around the mean, then you get a better looking map. There we go. Sorry, there we go. So you can play around with it a little bit. So these types of apps are fun to make and to play with, but like as Jeremy said, that's making a call to the server every time that you call that function. So you wouldn't use this in any production app, or many production apps, I should say.
Could you put the min value back up to average?
Yep.
No, yeah.
Oh, right here.
Slider, yeah. And then, yeah, close that. Zoom out just a little bit. Oh, it's still a little big, I guess. But this technique of setting the smallest value equal to the average is a good way to really focus in on the things that are above average. And you can also flip it around and look at what's below average by flipping the sizes around. Cool.
All right. And then this is just an example of, I'm not going to show you the code on this one. All these samples, by the way, are going to be on GitHub next week. I'm going to post them to my repo, and I'll show that at the end of the session. But yeah, this is an example of how you could just take a look at creating a bivariate exploration or application. So here it's percentage of the population that voted for Obama, and maybe I want to show also the unemployment rate, and you can explore areas where I think it's interesting to see areas of high unemployment that voted for him, but also these areas of low unemployment that did. So sometimes, these pundits on the news will say, oh, these angry voters, wanted to throw this person out or vote for this person. But, that may be a regional thing. So you kind of see those geographic patterns in a map like this.
This is it. This is the fun part of it. Like, you can see how excited Christian gets looking at these things. And you never want to lose sight of that. This is really the fun part of your job, playing around with this, with interesting data and creating these visualizations.
My whole job is fun, Jerry.
Oh, so
I love my job. Okay, so let's talk about some new stuff since last Dev Summit. If you came to the session before, these are new. There's heat map render, so it's only with points. You want to create this continuous surface to indicate hotspots. It's not like analytic hotspots where you run a geoprocessing tool. It's just a quick look at where more points exist in your map. And then dot density. This was what I demoed in the plenary a couple days ago, and this one I'm really excited about because I think we can do a lot of things with it, a lot of things that we haven't played around with yet. But But yeah, we can show these off right now. Let's see here.
Yeah, dot density is in the 3x API, but it's way slower than what's in 4x. So it's definitely worth a look at again.
Yeah, so I'm not going to show all these samples, but this is the heat map renderer. It doesn't work well across all scales. It really only works well at 1 or 2 when you set it. This is fraud incidents in Southern California, and so you can see areas that tend to have more than others. But as you zoom in, you'll see that it changes a little bit. So what looked hot up here at that view scale now isn't so hot, but downtown San Diego is going to show a hot spot. But then you get down a little lower, then it doesn't make sense at all. So just display your points. So that's not built into the render. I had to set a watch on my view and flip the renderer in order to achieve that. If you're interested in that visualization, we can talk about it after. There's earthquakes. So here's the dot density demo I showed just a couple of days ago. I won't focus too much on it now just because I'm assuming most of you were probably there and you saw this, but it's cool because you can zoom in to different areas, and this dot value automatically updates. That allows you to see the same density across scales. If I set a hard value, which you can do with the renderer, you'll get a vastly different look as you change the scale. I made the legend more interactive. This is not this is the out-of-the-box Esri legend, but this is not out-of-the-box behavior. You have to do additional things to it in order to filter. So, or not filter, but change the colors. Do you have a?
You go ahead.
Okay. So I also built this app. I think I'll put this out in a couple of weeks whenever we release this in the API. This is coming in 4.11. The dot density render is. And I'm going to blog somewhat extensively about it, some of the things you can do. So this is an app that I created just to explore the different properties of the render. So here we're taking a look at a layer of crops. So let's say, do we have total crops? Oh, it's not focused on.
Yeah, total, it's at the bottom.
Total acres?
Yep. So
here it's total acres of harvested crops. And I can change the dot value dynamically here, and I just love how fast this renders. Like Jeremy said, in 3x, this was not possible. It was terrible, the performance. But this allows you to kind of see how what value works. So maybe I say one dot is 20,000 acres or something. And so you get this visualization to show where people grow crops in the United States. But it's more fun to show multiple colors. So let's say you want to do corn, wheat, cotton, let's see, soybeans, vegetables.
It's pretty hard to see on the screen.
Is it hard to, oh, that's too bad. Let's see here.
I don't know if any of the other ramps are any brighter.
Let's try that. Let me bump this down a little bit too. Let's see here. Is this better? What was that? Yeah, number 13. It's a good one. Can you guys see those colors okay, or is it kind of hard on the screen?
Probably close enough. Okay.
So you see that as I bump this down to 1, you get an interesting look. Do you want to talk about this, Jeremy, this concept of blending?
Yeah, maybe turn it off first. A traditional dot density doesn't blend. The dots just coalesce, and the dots that are more, if there's more dots of a certain type, they're going to cover the other dots. And so you'll just basically see that dot. Then we've had the idea in the past of, when it's a hard cutoff like that, you don't get to, you lose out on some of the patterns. So that's where we've been experimenting with blending them together. So as the dots coalesce with each other, the majority ones that are on top are not going to block the others. They're going to be weighted and show more, but they'll blend with the other colors that they hit.
Yeah, we try to be sophisticated here so that you see there's a little bit of blending up in this part of South Dakota, but if we don't want to, we want to make sure that we give the proper amount of weight to the attributes. So in that case, if What's this pink one? Is that wheat? I think it is. Yeah, so wheat is in that, but there's a little bit of corn. You want to not make corn and wheat equal. So we're very conscious of that when we design the renderer. I really like this one in particular because it shows this concept of fuzzy boundaries. And it also shows how well dot density relates to predominance.
Yep, very well related. But the other thing is that this is 1 dot per acre. Probably not realistic because it shows that the country has got way more crops than it really does. And then as you tune it down to get it to more relatable number that really emphasizes the places that actually grow crops from the places that don't, you kind of get that look.
Well, and this really shows where dot density does better than predominance. So we go down here, we get this predominant looking map. Obviously it has the blend, which is different, but you have areas like San Bernardino County and also Clark County, Nevada, that show a lot of data, or even this county up here in Nevada. A predominance map would just give a solid color to that, no matter the amount by default. But with the dot density, you get that up to the dot value you want, and those values go away. And so that's really a more realistic picture of what the crop or agriculture is of that geography.
You can also add this, for the predominance one, you can add the size, which will tell you, a small circle, that means there's not much growing there. But that is almost distracting, I feel. This is where dot density excels over that, like you say.
And some caveats too with dot density is we're just randomly rendering dots essentially within these polygons. So when you create this visualization, you want to limit your scale to the user. So you don't want them to be zooming in this far and being like, oh, there's no crop in my backyard, because obviously there's not. This is just a rendering technique to show density. It's not.
For like this data set, it's counties. So it's a county with a value for wheat, cotton, soybeans. And that's all that there is. So it's really no finer resolution than county level resolution. We're just playing with how we color things in that county.
Yeah, so you could see that with the outlines here. And so this is when I'm not using scale. If I check that, this same density is going to go as I zoom in. So you may have seen that change. If I uncheck that, then you see that density is not maintained. It actually looks a lot less dense. Let's see here. We only have a couple of minutes left. Let's just finish up here, I guess. You wanna?
We've feature layers have gotten faster. First, we can do way more on the client than we could before. Everything is rendered at WebGL. Starting at 410, both 2D and 3D is completely rendered at the WebGL stack. That means we can do way more amounts of features than we could with previous technology like 3X. And it's just a single context too. So we've had WebGL for a while now, but it's been individual. Each layer had its own WebGL context, and then you might run it. If you had a lot of layers, you'd run into these like out of context errors of Chrome. Now you won't get that anymore. It'll all be one map. And one WebGL context. So we can display a lot more data. We request a lot more data now that we can display more data. We've improved the performance of getting the data from the server to the client by leveraging PBF. Feature layers with feature tile caching on the back end that happens automatically for you. You don't have to do anything. And just trying to improve how much data we can bring to the client.
So, the question we get all the time is, how do I visualize lots of data? And we're doing everything we can on our end to improve that experience. That's what Jeremy just talked about. You can display all of it. You could cluster it. Clustering isn't available in 4X yet. We're really pushing and trying hard to get that in there this year. But if you want to cluster your points, you need to use 3X for now. And then heat map is another way to do it. You can also be really interactive in your applications. I'm not going to go too deeply into this just because, one, we're out of time, and two, we have other sessions that cover this. So in this particular app, there we go. I'm looking at homicide data. So it's a bit of a morbid topic, but this was an article done by the Washington Post earlier, I think last year, where they issued these FOIA requests to different cities because there wasn't a national database on homicides, and they wanted to see how many cases were solved and how many were unsolved. I'm a big Dateline fan, so I was really interested in this data. And so we pulled down the CSV and published a feature layer, and I built this app to explore it. So it's, you look at it by year, and it's really shocking to see the number of unsolved cases by city, and a little disturbing in some ways. And you can break it down by the gender of the victim, the race of the victim, and the status of the case. So here the red means it's still open. There wasn't an arrest made in that case. So you see, by geography, you can explore, highlight, and each time I move the mouse, I'm actually querying the layer view client side for the stats, and I'm pushing them to all these charts. So there's a lot of stuff going on all on the client. And that's just an example of how you can build a data exploration app for your user and allow them to do that.
We feel that this is really the next step. Like we've got really good 2D visualizations, and this client-side interactivity where we're dynamically querying the data directly in the browser will really open up these types of applications. So not only can you visually look at it, but you can quantitatively ask questions of it. And there's a session, Jan, I see you're in the back. What time is your session on client-side interactivity? Tomorrow afternoon. Sometime. So look up Jan Cabone in the Agenda app, search for his name, and you'll find that that's definitely one to go to learn how to build the app, a similar app like Christian showed.
Yep, and so we have to end. Thanks for coming out, but I want to point you out to these resources. We have a Get Started with Visualization page in our guide in the documentation. I try to blog as frequently as I can about visualization, data exploration with our API. These links are available to you in the slide deck that will be made available, but these slides are also in my repo that I'll show you just now. We have dozens of samples in the SDK that showcase these concepts, and please rate this presentation on the Esri Events app so we know how we did as presenters and how relevant this content was to you. If it's not relevant, then let us know and we can adjust it accordingly. Let me go back to my browser and show you this repository. So if you go to, this is my, I guess I can't bump up there we go. Take a look at this conferences repo that I have, and go to DS 2019, and then you'll find all my sessions and slides, demos will be linked to there. It's not up to date right now. I pushed some stuff up a few days ago, but there have been changes. So go ahead, download the code, play with it. Let me know if you have questions. And if you have use cases or ideas, I've already spoken with some of you about some interesting ideas, and I'm really excited to try it out and see where we can go with that. So with that.
One last thing. If you're interested in sort of rethinking some of the different map styles that maybe you've tried before, you want to try them again, Jim Harries and I are doing a session next door right now, or right after this session, that looks at not the development angle of it, but just showing you different examples of different map styles that work with different types of data. And I think all of our data, most of the examples are Seinfeld related, so it should be a little fun. And thanks.
Yeah, thanks for coming.
Cool, yeah.